terms of the danger level. Pretty crazy. Okay, so I'm going to write it up here, 7.5. Language of functions. So it's a lot of vocabulary here. Then, I don't know, Jackson, I don't know if you're on here or not. But something that we can do is we can go to Zoom. If you are on there, Jackson, and you want it to be Zoom so that you can ask questions right in the middle of it, we can do that. Then the other thing is you can also just hit me up with email questions. You can even hit me up with email during the discussion. And I'll try to watch my email and see if anything comes up. But this is what we're at. So a function. A function is the result of an equation. Think of it that way. And you know what we've done in the past is we've written an equation like this, for example. Y equals 3x plus 7. That's an equation. If you graphed it, it would be a straight line, be pretty steep. It'd cross at 7. So that's what it would look like when it gets graphed. That's one example of an equation. Now, is this a function? And the answer is yes. And this is why it's a function. It's a function because if I made a table of values and I said x was equal to 0, what does y have to be?
0.
Put 0 in, what does y equal? Three times 0 plus 7 equals 7. 3 times 0 is 0 plus 7. What if I put 1 in here? 3 times 1 plus 7 equals? How much? 3 times 1 is 3, plus 7 is 10. If I put negative 1 in here, 3 times negative 1 equals 3 times negative 1? 3 times negative 1 equals negative 3. Negative 3 plus 7 equals?
I thought you were asking.
Oh, the answer, no. Okay, good. Equals 4. So there's only one answer, right? There's only one possible outcome. So in this situation, all of these numbers are what we call the domain. Those are the input values. I suggest you write this down because it's going to come up. These are the input values. Sometimes we refer to these as the independent variable, like in science they talk about that. This is the independent variable. And the reason it's independent is because it does not rely, its value doesn't rely upon something else. It's independent. Whereas the y values, those are dependent variables because the y depends upon what that equation says. And the y is what we call, the output is what we call the range. So these are the output values. And they are dependent upon the rule. And the rule here is 3 times the input plus 7. So another way to look at this is something that you may or may not have seen like in elementary school. It's something called a function machine. So what we're going to do here is we're going to say we have a machine and we can take numbers and we can put them in, and then from that machine out comes an answer. This is how they teach it to little kids, but it makes a lot of sense. It's nice to look at. And here's what the rule is. The machine's rule is 3x plus 7. You know, when they do this with like little kids, they'll say, well, the rule is going to be add 6 or take away 1, stuff like that. And if I take an input over here, I'll get an output. And with a function machine, if I take the number 1 and I put it in, I'm going to get 10 out. If I take the number 0 and I put it in, I'm going to get a 7 out. So whatever it is that I put in here, I only get one number out. That's what makes something a function. So if a relationship is a function, that means that you only can have one possible answer for each input. So a function, I mean, there's lots of ways of just, here, it's real formal. A direct correspondence where one input value has exactly one output value. So you could think of this as a rule where you have one input gives one output. This is key. You only have one answer. And you may say, well, isn't math like that all the time? But math isn't like that all of the time. Sometimes there's more than one answer. Eventually we'll see things that are like that. But for now, let's go back and look at all this stuff that we have written here. So this right here, y equals 3x plus 7, that is a function. It's a function because for every single value you put in, there's only one possible answer. There's no way to get two choices for your answers. And when something like this is graphed, it goes like this. If I went to this value of x, how do I find the value of y that goes with that input of x? Using the graph, if this is my input, where is the output? How do you determine what it is? We've done this with numbers before. So for example, if we said we had an input of 1, what's that? Well, you're going to go up, 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 and hit, and then you're going to go over, and you're going to come right here. And if you have an input of 1, what's the output? That's 10. So for each input, there's only one output. And another way of doing this is if you go anywhere on this graph, and you drew a vertical line like this, it's only going to cross at one point. That's called the vertical line test. So when the question is this, the question is that a function? You can look at the graph, you can draw a vertical line. If it only crosses the graphed line in one place, the answer is yes. This is called the vertical line test. So there are some functions out there there's some equations out there, don't draw this, but there's some equations out there that might look like this, for example, when you put them on the graph. And is that going to be a function? According to the vertical line test, no. Because according to the vertical line test, if I did this input of x can give that output or this output. It gives two answers. So, let's say that this is 4, and that ends up being 12, and that ends up being negative 12. That doesn't make sense that you start with a 4 and you could end up in two different places. We haven't learned math that way. So all the math that you guys have been learning all these years has been really functions. Because we're used to having one correct answer. Not two answers to choose from. So we can check to see if something is a function by doing several things. We can look at the domain and make sure that each value in the domain has only one output or one range value. We can draw a vertical line through the graph and see that it only intersects in one point. That's another way we can do it. So how does this change if it's written as a function? If I say that this relationship here is a function, then we would write it like this. F of x equals 3x plus 7. And really, that just means that your output is written f of x. So why write it differently? Well, it's like a more specific statement. Not only are we saying that this is the relationship, you start with x, you multiply by 3 and add 7, but beyond that we're saying this is a function. So it's being more specific in our description. And why? You just gotta be patient, give it time, and eventually you'll learn more and more and more stuff that it'll start falling together, and you'll say, oh, that's why we call these functions. We just say that's an equation. This is an equation right here. That's a function because it passes the vertical line test. So here's a function. This is called a reciprocal function. Y equals 1 over x. So this is example 1. Can I erase this? You guys are okay with it? You know, if you don't like writing everything either, and I fill a board like this, and you wish to shoot a picture of it, you are welcome to do so. You're welcome to do that. I don't mind. You're just going to tell me, hey, wait a second, I like to shoot a picture. So example number 1. So they have a reciprocal function, and it's like this. Y is equal to 1 over x. So really, we could write this thing, f of x is equal to 1 over x. That would mean exactly the same thing. It says, and it pairs numbers with their reciprocals. So let's just see what they mean by that. What if you had 4 for an x value? What would this function give for a y value? What? You just put it in here. Just put a 4 in there. Y is equal to 1 over. Yeah. So these are going to be the reciprocals. What if I put a 2 in here? What does y equal? Just a half. If I put a negative 6 in here? Negative 1 over 6. Yeah, remember that that's the same as 1 over negative 6. Negative divided by a positive is the same as a positive divided by a negative. What about a 0? Can you do that? Can I just say that that's equal to 1 over 0? You guys are kind of doing this. No. There's no solution. Because we cannot divide by 0. No division by 0. Not allowed. It's undefined. Division by 0 is undefined. So when this thing gets graphed, it looks like the domain could be any number except 0. So the domain, and here's how we can write this. It's going to be all real numbers. However, x may not be equal to 0. That's how we write the domain. And then there, when the value of x is 4, we've got that written down already. Y is 1/4. So you have a graphing calculator. Graph this function under a standard window. So you go to y equals, right? clear whatever you have there, just 1 divided by x. And then if you go to zoom and just hit number 6 right away, it puts it in a standard window. So you don't have to change your window manually. What's it look like? It's 2 different lines, isn't it? And they don't cross the y-axis. No, they don't. Well, let's see what your y equals says. Okay, let's go to where it says plot 1 with your arrows. Turn it off, hit enter. No, you don't hit clear. You turn it off by hitting enter. There you go. Now go to zoom, number 6. There you go. You have a graph, Fiona? Marvis? Right. That shape of a graph, that's called a hyperbola. Hyperbola, H-Y-P-E-R-B-O-L-A. And when that thing graphs, it does this, and it does this. And that line never crosses the y-axis. You think about this, if you will. Let's say you had 1/10 as your x value. What is the y value going to be equal to? That's going to be 1 over 1/10, which is the same as 1 divided by 1/10, which is the same as 1 times the reciprocal. So that's 10. And if you had 1/100th, it'd be 100. So the smaller the fractions get, the bigger the numbers are. And the bigger your number is, the smaller the fraction is, because the output is the answer, the reciprocal of the input. And the same thing happens in the negative direction. So you don't need to know this just yet, but that's the shape of it. That's a hyperbola. There are lots of things in nature that follow hyperbolas. Okay, so let me think what I got here. Oh, I just have these 3, sweet. So what are the domain and range of the function described by the equation? So see, they're not even saying f of x yet, but they're saying it is a function. Y equals 4x minus 3. So we can also write it as f of x is equal to 4x minus 3. So what's the domain? What are the numbers we can plug in and get answers? Can you use whole numbers? 1, 2, 3, 4, 5. Can you use negatives? Negative, so you can use all the integers. Can you use decimal numbers? Could you put 0.1 in here? Could you use fractions? Could you put pi in there? 4 times pi minus 3, sure. Can you put 0 in there? 4 times 0 minus 3 equals negative 3. So in this case, we say that it's all real numbers, or all reals. There's no restrictions. This one here, we said the restriction was all the real numbers except that x could not be equal to 0. That happens a lot. Okay, then the range. So what kind of answers can we get? Could you end up with the answer 1 if you put the right number in here? Could you end up with decimal numbers if you put the right thing in? Could your y value be negative numbers? If you did the right number, could you get 0? Probably, yeah. So in this case, the range is all reals, all real numbers. So that kind of leads us into, well, what are the different domain and ranges, the different groups of numbers? And we've done that bit by bit, but we haven't really put them all in one place yet. So the commonly thought of groups of numbers for domain and range. These are the commonly used ones. The most common, two vertical lines like this, and then turn it into a capital R. That's real numbers. So that's everything. That's decimals, that's fractions, that's negatives, that's positives, that's zero, pi. This is basically everything that you can think of as numbers that you know about right now. There's whole numbers. Zero, one, two, three. So I'm writing this as a set. Here's the pattern, 0, 1, 2, 3, and then dot, dot, dot. It continues forever. There's integers. And integers are whole numbers and their opposites. So here's what I do. I say 0, 1, 2, dot, dot, dot. And then if you count it backwards, -1, -2, you could make it go that direction. So like the number line we had over in the other room, that was integers. So let's see, we got reals, we got wholes, we got integers. They have another one that they call natural. Sometimes we call it counting. That's just the whole numbers without zero. 1, 2, 3. So the big thing is going to be like here and here. Sometimes whole numbers get described with a different set of words. Sometimes they call them the non-negative integers. So these are integers. Those are the non-negative integers. Sometimes that gets said as well. So be aware of that in the reading. Okay, third example. So we go back to one of these equations that we were using for decay. So they talk about this car that's worth $21,000. And then it gets multiplied by 85%.
Orvis, your dad's here to get you. Grab your stuff.
Which is, do you have an appointment?
Yeah, I'm taking my permit test.
Oh, what time is it?
The test?
Yeah.
I have no idea, like the exact time.
Okay, read it carefully. Read this one carefully, or watch the last, I don't know how many minutes we're at. We're at 24 minutes.
Okay.
Watch it, okay? This one's important. So you have $21,000, which is multiplied by 85%. So this is a 15% depreciation. So then it keeps 85% of its value. So this is written in y equals bg to the x form. And then what they did is they said x, which means the number of years that it depreciates. So what is the range of the function? That's the only question that they're asking. So the range are all of the possible output values. So where do you think the numbers are gonna lie when we do this year by year? Are those reals, are they wholes, are they integers, are they natural and counting numbers? Let's start out. Can they be negatives, you think? Are you ever gonna have a negative value of something? The car could become worth negative money? Usually something gets down to where it's not worth anything, right? Then it's zero. So zero, yes, but it's never gonna be like negative $20. That doesn't make sense. No matter how much something becomes worthless, it never becomes negative. Although maybe it does, if you have to pay to get rid of the car. Yeah, like here we have to. Down in the States you don't have to. So I'm sitting there with my plow truck with a blown head gasket. If nobody takes it from me and I don't fix it, I gotta pay to get rid of it. That sucks. We might fix it. So it's not in integers. So are we gonna be limited to whole number dollars? Like $10, $11, $12? What happened with our answers when we did some of these kinds of problems? Did we end up with cents? Yeah, so that's not an integer anymore. That's a decimal number. So I think where we're at is it's gonna be reals. But the question is, all reals? Is this ever gonna be worth $100,000? If it loses value? No. So when you graph it, where does it start? $21,000. So that's where it starts, and then it does something like this, right? Does it ever reach zero? It could. You might get down to like 1 penny and you cut that in half and now you have to, if this is zero and that's 21,000, the range gets written like this. It goes from 0 to $21,000, and it's like this. The value of the car is going to be more than or equal to 0, and it's going to be less than or equal to 21,000. That's how you write the range. We can also write domains like that. You know, if we were going to do the domain, we would write it in this form. And they ask us to do this quite a bit. The domain would be the x values, and where do they start? What's the smallest x value? 0. And then it's going to go out to something. We don't know. I mean, if this was just numbers and we weren't saying that it was dollars and pennies, that number would never, ever, ever become 0. So in this case, we might say that it's equal to 0 or more. Give me 1 year, 1.5 years. And this can also be real numbers, and this can be real numbers. So the big thing with this lesson is they're just trying to get us to realize, where do numbers come from that we use in equations? How do we describe what those values are? Here they're saying that y is going to be more than 0, but I guess my interpretation is that eventually that car is going to be worth 0 cents. Numerically though, it will never ever be equal to absolutely 0. So that's what I have. Send you out of here with some homework.